like an infinite mass and infinite volume. I know that they can suck up anything, including light, and I know that I think they found one in the center of every galaxy, and that's all I know.
Infinitely dense masses? Is that the right answer?
So a black hole is an object that you can have so much mass squished into such a small space such that light can't escape. So it's something where the escape velocity at a certain point is greater than the speed of light. So if you get a little bit, we call that the event horizon. If you get a little bit closer than that, it's too much mass in such a small space that the gravitational pull is so strong that you can't escape.
I know they can happen after a star dies. Other than that, I don't know.
When sun's supernova.
So we don't really know what physical process causes them to form, but we know how they form in terms of what things can happen in the universe to make them form. So there's two different kinds of black holes. There are what we call supermassive black holes that exist at the hearts of galaxies, and there we call stellar mass black holes. The stellar mass black holes, we have a little bit better idea about them. They form from the collapse of a massive star. So it's near the end of the star's life when it no longer has fusion pushing out in the core, so therefore it's got no pressure out, it's got all the gravitational pressure pushing in, and so the core collapses. And if you have enough mass, there's nothing that can ever stop the collapse. Now the supermassive black holes, we don't quite know. We know that we believe at the center of the heart of every galaxy lies a supermassive black hole. When we say supermassive, we mean things that are millions to billions of times the mass of single stars. But we don't know how they came to be. It's kind of a chicken versus the egg problem. We don't know if the galaxy formed first, and then heavy stuff sank to the center and coalesced, and then eventually became a supermassive black hole. Or did the black hole form first, and the galaxies kind of form around it? So we currently don't have an understanding of which direction those things happen in.
We don't really see the black holes, but we see light and other objects disappearing into the center of something that we see in a telescope.
You can feel the effects of their gravity.
So we've had to do a lot of indirect observations. So black holes, by definition, we can't see them, but we can see their effect on their environment around them. So a couple of ways. We typically have inferred that they exist by detecting something of really high mass in a really small space. Even if we can't see what that mass is, we can use other constraints to figure out where it is. So the very first black hole that was ever discovered was really found it was a binary system, and we could see that one star rotated or orbited around something else, and with its period we could figure out how massive the object was in the center. And so we got that this thing had to be several times the mass of a star. And then we used other observations to figure out that whatever was in the center was very small. So again, you had this idea that you had a lot of mass in a really small space. One of the best supermassive black holes that we know about is actually at the very center of the Milky Way galaxy. And there we use orbits of stars. So we figure out that stars, by their orbit, can tell us exactly where the center that they're orbiting is, so we can figure out how much mass there is. And by how close they come to the center, we can then confine whatever mass is there to a really small space. And so at the center of the Milky Way, astronomers have been able to prove that there's 4 million suns worth of mass confined to an area smaller than the orbit of Pluto. And so the only way you can squeeze that much mass into that small of an area is if it's a black hole. So my research was actually working on this supermassive black hole at the center of the Milky Way galaxy. And so what we were doing was we actually were studying stars that were orbiting around the black hole and using their properties to figure out that the black hole was there. We watched how bright they were, we watched how long it took them to move around in their orbits. And as we got more and more sure of exactly where the black hole was, we could refine our techniques and actually look at that spot. And one of the things we found out was the black hole wasn't actually black, that we actually were seeing light that we thought was coming from the black hole. But it wasn't coming from the black hole itself, it was coming from the accretion disk, the disk of material around that was kind of spiraling in to the black hole itself. So when that material gets very hot and very turbulent, it lights up. And so we were able to actually see the light from the material that was going into the black hole itself. Most of the studies that are trying to detect black holes are looking for their gravitational effects, either by looking at orbits, looking at how gas moves around the center of a galaxy, how binary stars might move, how other stars in a cluster might move to see if there's a black hole in the center of a cluster. So we're typically trying to look for the orbital properties of things around the black hole to infer there must be something really massive in a really small space.